Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 11 to 15 of the next generation Accuplacer quantitative reasoning, algebra, and statistics practice questions. Let's take a look at question 11. It reads, Jacoby followed the recipe that requires 2 cups of water for every 3 cups of flour. If he used 8 cups of flour, how many cups of water did he use? To get started, let's take a look at the formula that will guide our problem solving process. Okay? Now, whenever you see problems of this setup involving a pair of measures with two different units, what you want to think about is proportions. Okay? So we're going to be using the proportions formula here. So now let's assume that the x's and y's coordinate pairs are in proportion. Okay, so if they're in proportion, what we'll have is the following setup. So they're in proportion where, let's say we have an x1, y1 pair, x1 over y1 is going to be equal to x2 over y2, and that this ratio keeps on going forever. Okay? Now what you want to keep in mind is that we're looking at a pair of measures. So let's say the x's are the first measure, so we have measure 1 as the x's and measure 2 as the y's. Okay, so we can set up a proportion like this and we can solve this resulting proportion. Now in this problem right here, the unknown is the amount of cups of water to use. Okay, so let's declare that variable. Let's say let the amount or the number of cups of water equals, let's just call it C. Okay, now we have two measures in this problem. What are the measures? We have cups of water and cups of flour. We have 2 and 3, that's the first ratio, and then we have 8 and another ratio that we do not know. Okay, so we have 2 goes to 8, and then we have 8. Well, this one is cups of flour, so the unknown, which is C, cups of water, goes to 8. Okay, now in order to avoid mixing up values when you're setting up your proportions, it's good to explicitly state what your units are. Okay, so we have measure 1. Measure 1 is number of cups of water. Okay, so number of cups of water. So that will be our numerator position. Okay, and then we have another measure, measure 2. Can you determine what measure 2 is going to be? Remember, there are two units here. We have water and flour. So flour will be the second measure, number of cups of flour. So please clearly state what units the numerator and denominator are first before you start setting up your proportion. Okay, so the first ratio, 2 cups of water, it goes with 3 cups of flour. So 2 is for water, so it goes in the numerator, over 3 cups of flour. Okay, so 2 cups per 3 cups of flour equals, now we look at a second statement, 8 cups of water. Does that go in the numerator or the denominator? For the second pair, 8 cups goes with flour, so that goes in the denominator. Okay, so stating the units clearly helps you set up the problem. And then the unknown, what we're looking for, the amount of cups of water that's used for 8 cups, we declared that as C. We'll just put it in the numerator here. Now let's get C by itself. That will tell us the number of cups of water for 8 cups of flour. To get C by itself, we're going to solve this resulting algebraic equation. Since C is being divided by 8, we're going to undo that by using the inverse operation, which is multiplication. So we'll multiply both sides of the equation by 8. On the right side, these two divide out. So that leaves us with C equals 8 times 2 over 3. When you want to multiply an integer with a fraction, it's helpful to express that integer as a fraction and follow the procedure of multiplying numerator with numerator and denominator with denominator. So that becomes 8 times 2, which is 16, over 3 times 1, which is 3. If you write this as mixed numbers, 3 goes into 16 5 times, remainder 1, because 3 times 5 is 15, remainder 1 to get to 16 over 3. Our answer for question number 11 is option C. Okay, you will need 4 1/3 cups of water for 8 cups of flour. Alright, let's take a look at question number 12. It reads 4 times the quantity x plus 5 plus 4x plus 8. Which of the following is equivalent to the expression above? So one tip you would like to keep in mind concerning factorization, to be more specific, when it comes to factoring out the GCF. Now, what process can that be likened to? Okay, when factoring out the GCF, what are you doing to the numbers that you are factoring the GCF out of? You are dividing by, or you're dividing terms by that GCF. Okay, so when you're factoring out, what you're factoring out gets divided by that GCF. So keep that in mind, okay? Now we have 4 times x plus 5 plus 4x plus 8. Now we notice we have either one set of parentheses or none. So what we're going to do here is we have to distribute first and see how we can configure the terms in such a way that it matches one of these options. So we have 4, we'll distribute it to x and 5. So that yields 4x plus 20 plus 4x plus 8. Okay? Let's go ahead and combine like terms. Our first degree terms are 4x and 4x. 4x plus 4x, you add the coefficients, 8x, and keep the variable. And then we have 20 plus 8. So this becomes 8x plus 28. This option does not match any of these options here. So if you take a look at options C and D, they do not have any parentheses. So we know for a certainty that it cannot be D or C. Now what we're going to do is carry out a factorization that will enable us to determine the final answer. Can we factor out 8 from these two terms so that we get option B? 8 goes into 8x, definitely x times, but does 8 go into 28? The answer is no. Okay. How about 4? It looks like 4 works. 4 goes into 8. How many times? When you factor out 4, as we stated earlier here, it is as though you're dividing this term by 4, so you get 2x. Plus, if you factor out 4 from 28, it's as though you're dividing 28 by 4, and you're left with 7. Okay, you can multiply back out to check your work. As we can see, the correct answer to question 12 is option letter A. All right, let's take a look at question 13. It states it took Khaled 90 minutes to complete 40 tasks. Which of the following is an equivalent rate? So 90 minutes to 40 tasks. That's a ratio right there. So whenever you're setting up a statement that two ratios are equal, we have a proportion. So that automatically means we are going to be using our proportion formula again. Okay? So formula for this is proportions. Remember, if you have two measures, measure 1. They say they are x's, and measure 2 are our y's. Then in proportion, when we have a situation where the ratios x1 over y1 is equal to x2 over y2, and the pattern goes on forever. All right? So can you ID the two measures in this problem? We have time in minutes and number of tasks. Okay, so let's go ahead and write those down. Let's put the minutes in the numerator. Okay, so measure 1 is minutes. So we'll put the minutes term on in the numerator position, and measure 2 is tasks, number of tasks. Now, what are we looking for in this problem? So we can declare it. Okay, so we know that 90 minutes goes to 40 tasks. And then the question is, which of the following is an equivalent rate? If you look at the options here, what do you notice? All the tasks are pegged at the value of 10. They're all 10. So the only value that varies is the time t. So that's what we do not know. We do not know the time. We know for sure that the number of tasks is 10 because that remains constant in all the options. Okay, so what do we want to call it? Let's call the number of minutes for 10 tasks, let's call it m. Okay, so let m equals number of minutes for 10 tasks based on the setup of the options. Sometimes you can use the alternatives to guide your problem solving process. Okay, so the first ratio, 90 minutes to 40 tasks, gives us a fraction 90 over 40, and that's equal to a certain number of minutes. Let's call that m, our unknown that we declared earlier, for 10 tasks. Now we have set up a proportion that we can solve for the value m. To do this, we're going to get rid of this denominator here, the 10, by multiplying both sides by 10. You can multiply both sides by 10. Now on the right side, the 10's divide out. On the left side, you can divide out the zeros. Cancel out the zeros. That's equivalent to dividing by 10. So we have 90 over 4 equals m. Our options are in decimal format, so we need to make use of our long division process to convert this improper fraction into decimals. Okay, so we're going to be dividing 90 by 4. 4 goes into 9 twice. 2 times 4 is 8. Subtract, bring down the 0. 4 goes into 10 twice. 2 times 4 is 8. Subtract. 4 can't go into 2, so put our decimal point and add a 0 here. 4 goes into 20 5 times. 5 times 4, 20. No remainder. Our final answer is m equals 22.5 minutes for 10 tasks. Option letter D is the correct answer for this problem. All right, let's take a look at question 14. We have a table provided here. And the question is, the table above shows a survey of 50 registered voters in a city. each voter was asked whether they plan to vote yes or no on two different issues. If a voter who plans to vote yes on issue P is randomly selected, what is the probability that that voter also plans to vote yes on issue Q? So if you notice, conditions are being attached to our probabilities. We are looking for a probability that someone votes yes on Q given that they plan on voting yes on P. So what kind of formula are we going to use here? We're going to use a special type of probability formula, okay? And that is known as the conditional probability formula, okay? Conditional probability. Okay, so what is the formula? It's as follows: the probability of an event A given B is equal to the probability that they both occur, A and B, divided by the probability of B. Okay? So this notation on the left side just simply means probability of A given that B has occurred. Okay? Probability of A given B. Pay attention to the order here. Okay, so let's adapt or apply this formula to this particular scenario that we're dealing with here. Okay? Now let's state what our events are. Event A is the probability that they vote yes on Q. Okay, so event A is yes on Q, and B is yes on P. Why did I structure it like that? Well, we're looking at A given B. We're looking at probability that A occurs given B has already happened. So if you look at this problem, if you look at the order, we're looking at the probability of Q, which is A, given that P, which is B, has already occurred. Okay, so that's why I set it up like this. Okay, so let's go ahead and set up the formula. So the probability of A is basically the probability that the person votes yes on Q, given given B basically involves yes on P. This can be determined using the formula, the probability of yes on both of them, on Q and P, okay, the probability of both divided by the probability of what? Can you guess what it is? If you look at the formula, it says probability of A given B is probability of A and B, which is Q and P, divided by what? The probability of B. So we're going to be looking at the probability of Q, okay? Probability of yes on Q. I'm sorry, on P. Okay, so whatever is given, that's what goes in the denominator. So you see given B, here is given P, so that's what goes in the denominator right here. Okay, this and is the same thing as this intersect right here, the equivalent. Okay, all right. So what are the values for the different parts of this equation here? The probability of yes on Q and P can be determined, the numerical value, by looking at the chart. Okay, so let's consult the chart. Where do we have yes on P and Q? This entire row is yes on Q. This entire column is yes on P. So the intersection is right here. That's where you have yes on P and Q. Okay, so we have probability of yes on P and Q is the value 8, the intersection of both. Okay? Now we need to find the probability that we have yes on P. Okay, so if you take a look at the rows, yes on P is this entire row right here. Okay, if you add them together, you get 20. So probability of yes on P is basically 8 plus 12, which is 20. Now we have all the information to compute the probability of yes on Q given P. Okay, so probability of yes on Q and P is the value 8 divided by the probability of yes on P, which is the value 20. Now let's go ahead and express this in decimal format. If you look at the options we have right here, they are all in decimal. So we're going to go 8 divided by 20. Okay, 8 doesn't go into 20, so what we're going to do, well, let's see. Oh, actually, I got it backwards. So the top one goes into the division bar. So we're looking at 20. How many times 20 goes into 8? Okay, so 8 divided by 20. Alright, so we set it up like this. 20 doesn't go into 8, so we have to put a decimal point, 0 point, and add a 0 here. 20 goes into 80 4 times. 4 times 20 is 80. Subtract. So 8 over 20 is equal to 0.4. The answer to question 14 is option letter C. Alright, let's go ahead and take a look at question 15, the last one in this installment. It reads, which of the following values is equivalent to 5 raised to the negative third power? So to help us with this, let's recall the specific formula known as the reciprocal property. Reciprocal property of what? Reciprocal property of exponents. Do you remember what that property is? It is x raised to the negative n equals, now this is the idea here, if you have a term with a negative exponent, that negativity can result in that term being reciprocated. Reciprocation involves switching the position of the term. If it's in the numerator, it goes to the denominator. If it's in the denominator, it goes to the numerator. So since x to the negative n, using the format of the given value here, is in the numerator, this negative sign attached to the power or exponent will result in the reciprocation of x and n. So it's going to become 1 over x to the n. Notice upon reciprocation, the power assumes the opposite sign. Alrighty? Okay, let's apply this idea to this particular problem. We have 5 raised to the negative third power. How can we rewrite this exponential term without this negative exponent? We apply the reciprocal property of exponents, which means that the 5, which is a numerator here, gets sent downstairs. It gets reciprocated and it becomes 5 to the third power. Notice when you switch the position, the sign of the exponent changes, becomes the opposite. Okay? So if you look at the options here, it looks like we have to expand it fully. So if we expand this fully, 5 to the third power simply means we multiply 5 by itself 3 times. Okay, 5 times 5 is 25, and then you just multiply that by 5. 5, 2, 5, 2, 10, 125. Our final answer is 1 over 125. Answer to question 15 is option letter B. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, the Accuplacer exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about what we covered in this tutorial or any math related questions for the Accuplacer, just place it in the comment section below. Don't forget to subscribe to our channel for updates to other math tutorials such as this. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.